Hello everyone! Hello Wrocław! How's it going? Good? Okay, my name is Timo. In software mention, I am the maintainer of React Native screens. On GitHub and social medias, you can find me with these handles. And it's quite really cool, and I'm glad that as developer of screens, I have this opportunity to tell you something about a native navigation in the JavaScript world. At Software Mention, as developers, we've been doing a lot of things lately. I bet you've heard about React Native IDE, a brand new VS Code extension that helps you to debug and inspect your React Native application. Previously, access to the React Native IDE was limited to a closed group, but at the recent App.js conference, Krzysztof Magiera, creator of the React Native IDE, announced an open beta for everyone. You can right now from your desktop download it for free, and I encourage you to check it out. It's a really neat plugin. But obviously, this talk isn't about React Native IDE, so let's keep going. We've been also working on improving our libraries. In React Native Screens, we've added custom screen transitions, a brand new feature that allows you to use and make your own custom transition animations while making a go-back gesture. Also, React Native Gesture Handler, our library that makes writing a gesture support easier, additionally got new documentation. And hey, there's new React Native Live Markdown library that has been created in collaboration with Expensify. And when you're thinking about open source libraries from Software Mention's house, what basically comes to your mind is probably Reanimated, React Native Gesture Handler, React Native SVG, but there's also that one library, right? Was it called React Native Screens, I believe, huh? Yeah, so I have actually two questions for you guys. So question number one. How many of you know React Native Screens because it's just a required dependency while installing a native stack from React Navigation? Okay, great. So for those of you who raised your hands and don't know what Screens actually does, I will come back to that later, just so you know what you're installing in your package JSON. But there's also question number two. How many of you know what React Native Screens actually does and why React Navigation uses it? Okay, I thought about that. So let's jump into the navigation-related topics. So let's imagine some scenario where user wants to create a navigation just to jump between different views that does specific things, same as it Facebook, Gmail, or even settings app from your phone does. You can see here that it's possible to move between some of the subviews like About from the general page, or on the right side you are switching between some of the tabs. Normally, React Native does not offer any support for creating in-app navigation. When you want to change individual views on the screen, you need to effectively manage the state and render the corresponding view depending on it. Well, you can only imagine that while with 2 or 3 screens, this is a simple solution. With more views, things start to get really complicated. But there's also no fireworks there. You are basically returning appropriate view without any animations, any header, nor any state persistence. We don't keep any info about previous views. Of course, we can implement such animations and keep that state so we could jump to the previous views, but we certainly wouldn't want to reinvent the wheel. Well, and we think about this scenario, but what a beautiful world it would be if there were only ready-made solutions which would offer complete isolation of screens from each other and allow us to define the structure of our application. But interestingly enough, it turns out that such solution already exists. But I know what you would ask me, hey Timo, what are these solutions and how to use them? Well, here comes the answer. One of the most chosen library for navigation by developers in is React Navigation, at least according to the stateofreactnative.com, and by the way, you should definitely take part in the survey next year. It offers the ability to define screen-based application structure. It brings many different types of navigators like the classical JS stack, native stack, so-called button tabs, which lets you to render different views divided into tabs. There's also the drawer navigator. And what's the best is that React Navigation uses React Native Screens. Defining a navigation structure is fairly easy there. You need to simply create a navigator object. Usually you are doing that with create native stack navigator function taken from that import. Then inside your main component, you need to define the stack.navigator component. It's like a holder that will remember your defined paths. And then we are defining such paths with stat.screen components with the name and views we want to render. There's also the navigation container component, which also must wrap our navigator, just so React Navigation could control your app state and could link your top-level navigator to the app environment. Inside the screen or navigator, you can also define your own screen options, like the option how the screen should be presented, or option if header should be shown, or even if the orientation should be in portrait mode, or maybe in the landscape mode, or maybe in the both. However, what I need to emphasize here is that whether you are making with Native Stack Navigator, your own navigator, you're basically fully using React Native screens, and you're taking full advantage of all the possibilities that React Native screens just offers. That's because what's the difference between the React Navigation and React Native screens is that React Navigation offers an API that you are using in your apps and uses the information about all of the defined screens to use them in connection with native primitives given by React Native screens. As you can see here, on iOS example, every screens are being controlled natively. We can see on the native view hierarchy from Xcode that there's a RNS screen view component that represents a screen, a RNS navigation controller view controller that controls switching between screens along with animations, controlling the orientation, and basically everything's native there, nothing simulated. But you may wonder, and I'm regularly being asked about this, that if there's a native stack navigator, then what does the stack navigator do? In the simplest terms, while the stack on the native stack is being managed natively by OS-specific controllers, which means that iOS and Android themselves handle switching between views, just as in the native apps, like the settings app, the stack navigator is being managed entirely by React Native. Like, imagine a JavaScript array that is managed when the user wants to move from one screen to another, and which during that process unmounts the previous controller and mounts the new one as it moves to the screen. But all of these things on the React Native side. Yeah, that's what Stack Navigator does, but we can see a big performance loss by having everything happen on the JS side rather than the native side. Yes, we gain from the Stack Navigator on flexibility because we can change everything on the React Native. And we can see how much freedom we have in modifying or animating all the navigational components like the header, but we lose on performance, which we, however, care more about. Yet, what's also important here is that even if you don't want to use the native stack, you don't have to, and by default, you don't resign from using screens. Well, we can see in the screen from the Stack Navigator that there's a RNS screen component here, and it's not by mistake. That's because even if you are not using native stack, you're still using React Native screens. Why? That's a good question. Why does the Stack Navigator uses React Native screens even if we don't want to have native stack? There are two main reasons. The main reason is that whenever a user tries to move from one screen to another, the previous screen is being detached, resulting in unmounting its content. Because of that, React Native screens keeps only the components that are visible to the user, which saves the memory of the device. The state of the previous screens is still preserved in the React componentry, but React Native screens ensures all the content in inactive screens is gone. React Native screens also gives you additional features like React Freeze support. And most importantly, we need to again point out one thing. As I said before, React Native screens does not only offer a native stack, but rather it serves navigation primitives like screen container that holds all of the screens, or the screen stack. Because interestingly, while React Native screens was being made, it was rather an optimization solution for a classical stack navigator rather than a library that offers a native navigation stack. As you can see, this feature has been added only in 139 pull requests. Yeah, this bad boy can fit so much native navigation primitives. Yeah, And when you are using JS Stack Navigator, like you still have an option to resign from using React Native screens with that simple parameter, detach inactive screens. But I won't recommend doing that, because why would you need to opt out of all these benefits I've mentioned earlier? So, if we've already learned how to make our own navigation structure and what React Native Screens actually does, let's take a look on how it makes all of the magic under the hood, from defining screen to making it visible on the screen. Let's start from the beginning. As a user, we are defining all of the screens that are being passed to the navigator. Navigator passes these screens as so-called routes and passes them to the JS component called native stack view. I would say it's a component that processes all of the props and the information about routes to make an instance of native primitives. This is like the heart of React Native Screens, since it unfolds whole routes to make native primitives. Native stack view firstly creates a screen stack component that maps all of the routes to the route view component. It's a representation of a single screen view, but still on JS. This component controls how given props should be set according to the other different screen options we've provided. It also wraps screens with context, like header height context that returns the information about header's height with some hooks like use header height. But that's also the place where the render function is being called, obviously a function that renders the component associated with a given screen. It also adds some other components like the header config component, which is a special component that lets screens to control the header appearance and behavior. From route view, where screen component is being rendered, screen continues to process some of the props. I would say these props are being processed on the deeper level of screen, like that's the place where managing ref or creating an animated component of the screen goes. But it's also a place where React Freeze support, for example, is being added. Finally, all of the calls to the screen stack or header config are being transferred onto the CodeGen native components, and that's the place where React Native does all of the magic to render them on the native side. Woo! Yeah, I don't want to tell you what's going on the native side, since both on Android and iOS, that site is pretty enormous, but that's how it looks like in the nutshell. So, we've talked today about React Native Screens, we've discovered what it does, we've jumped on the React navigation and learned how to make the navigation in it, but there's also one more library which has recently surprised with its popularity, and it's the Expo router. So what's that? Expo router is a navigation library that shares the concept of a file-based router, which means that each file represents a single path. That's why in Expo router you can create a file under an app directory to make it resolve your screen to a specific route. For example, for creating a /home path, you can create a file in app directory /home.tsx to make that path work straight away. It is also used by default as a navigation solution in Expo-based React Native projects made with npx create expo app command, and you're still using React navigation syntax since it's based on React navigation. This means that it still uses React Native screens. And even in the documentation of Expo router, there's that point that says, built on top of our powerful React navigation suite, Expo router navigation is truly native, and platform optimized by default. That's the quote probably from Ivan Bacon, the creator of Expo router. I've checked that on GitLab, I don't lie. So how to make routes in the Expo router then? When a file is created in the app directory, it automatically becomes a route in our app. Let's say that inside that directory we would like to have index.js, home.js, and user.js in square brackets files. You can tell, and it's pretty straightforward, that index.js matches the root path, home.js will match /home path, but what user.js does is that this route will match dynamic paths, where you can type whatever you want, like /abc or /tboba, right, like there. Pretty cool, huh? To make more complex routes that will match one after another paths, you just need to make another directories, and that's all. There are also special files with reserved names like _layout.js, where you can define a structure of given paths and set different options of screens. Well, you can see here that the syntax of this file is quite similar to the React Navigation API, isn't it? That's what I've meant about the similar API to React Navigation. Even if the approach for defining the navigation is different, underneath is still React Navigation. Expo Router is just one layer above. But seeing as I'm now narrating and highlighting the positive aspects of Expo Router, you might be wondering, what should I choose then? Should I choose React Navigation over Expo Router? Or should I prefer Expo Router and migrate my whole application if I'm using React Navigation right now? Let's compare both libraries. Expo Router boasts of having better developer experience and more features like automatic deep linking, type safety, static rendering on web. You get it in advance once creating a project with npx create Expo app, but it might be harder to learn and understand for newcomers that doesn't know much what these layout files are and what given names mean what. On the other hand, React Navigation is still the most commonly used library and has better community support. It's more straightforward since you are getting what you see in the code. Defined screens are just screens with given names, and it still has great developer experience, even with great type safety. Yeah, we will come back to that later. In my opinion, Expo Router is a really neat library that's for sure worth trying, and I would love to use it in my new projects. But for me, React Navigation is still just fine. In existing projects, I wouldn't throw myself in at the deep and rewrite everything to Expo Router, but it's still worth giving a shot. For more information about how our library React Native Screens powers Expo Router, I invite you to check my article where I describe in detail all the advantages that React Native Screens gives for the Expo Router. But in the previous slides, I had that one point. Still great developer experience, including type safety. And it turns out that the developer experience will become even better since there's React Navigation v7 announced. What's interesting about it is that it will bring static configuration API, which will allow you to create navigators as an object inside the createX navigator functions. This will bring, say, simpler type checking with TypeScript, along with easier deep linking setup. You can, of course, mix static and dynamic configuration, where, for example, you could have top-level navigators written in a static way, where deeper navigators could be written in a dynamic way. You can also define screens in a more advanced way by giving them options, object, or a linking configuration, as in this example. Of course, in this way, providing screen parameter is obligatory, like we need to know what view should we render for a given screen. For more information of the new static navigator API and other features, such as screen preloading, you can visit also official React Navigation documentation about upgrading to v7. But there's one more thing. Because, we've covered nearly everything about the news in React Navigation. But we also need to cover what will the future bring into React Native Screens. And oh boy, there's a lot of stuff to talk about. Let's start with Android. For the last time, we've been working on introducing material-free support for Android. Using Material 2 is really old-fashioned, even if it's still used by default in React Native. That's why we are planning to introduce support for Material-free, so that new React Native projects and even frameworks like Expo could opt in. One of the things that will bring better support for material-free design system are collapsible headers. Since there are currently three types of headers, large, medium, or small, it's good to support three of them in screens. There will be also a prop for natively aligning header's title to the sender. One of the also most requested features are form sheets on Android. One opinion I hear very often is that there's no support for modals on Android. Soon, these words will become a thing of the past, since form sheets on Android are nearly there. They are native, you can configure their radius, their distance, they just work as on iOS. And finally, one of the most requested features on React Navigation's board was that one feature, tablet dual pane support. I've also got some words for it. Lastly, we recently experimented with adding the support for it, and for now, I can proudly say that we've achieved a working proof of concept of split screen in React Native. It's working, but it's still in progress since we need to polish the API and serve the ready future for you. All of these things are doable, but without your valuable feedback about issues, we could not call the React Native screens perfect. If you have any bugs or feedback on how the React Native screens work, or you would simply like to make a contribution to React Native screens, scan this QR code and make it happen. That's all from me. Thanks.
Awesome job. Thank you so much. We have time now for some questions to Tymek. So who has any questions? I can start. But think about your question because I'm not going to let another speaker without questions from you. I have a question about the freeze. So I've read about the freeze like 2 years or 3 years ago. It was created at Software Mention as well. And does it work like by default when you have that screen component and that freeze parent? How does freeze work basically?
Basically, what React Freeze does is that like it freezes on the native views, previous screens, just that the render on the JS side won't like trigger the renders on the native side for the screens that are not visible. Mm-hmm. So like on the JS side, you can still like re-render things. You can still like observe the updates from the use effect objects, but they won't trigger the renders on the native side. I would say that React Freeze, I wouldn't say it's obvious, that it's still like in experimental state.
Okay, for the past 2 years.
Yep, it is still, but since it's working, like there aren't many like issues regarding the React Freeze. You can like just enable it with enable freeze option from the React native screens, and it will just work.
Yeah, it's a great optimization feature, so that it's like performs better with this turned on.